Today I'm going to show you how to detect a deteriorating quality trend in a repository, how to find the low-hanging fruit to turn this trend into a positive one, how to assess if it is critical to your business, and to get a refactoring solution in just 5 minutes. This gives us back the flexibility of a startup by breaking free from the technical debt that slows us down. So we can see between commits a negative trend. Let's compare the first and the last commit. We can see that we went from 2.05 to 195 overall rating and have a lot of deteriorations. 20 hotspots that are components that have a rating less than 0 in our Embold score even deteriorated more. There's a lot of change between those commits. Let us focus on the hotspots that are getting worse. So let us hope they are using speaking names in this project. There we go. Maven project sounds rather interesting and central. Let us check if it has other issues than code quality. The test coverage seems to be okay, not 100% line coverage. Not optimal, but there is a debate about it. This might be bad when it comes together with a specific anti-pattern. Test-hungry methods. What are test-hungry methods? These methods have a lot of possible mathematical outcomes that probably cannot be predicted by human. So if you see a test-hungry method, either refactor it or slap it with mutation testing, because you have probably no idea what it is doing. This seems all fine. On our heat map, we have our Embold score from 5 for good code green to -5 to very bad code red, aggregated from design issues, code issues, metrics, and duplications inside the components. There we go. Again, to find our Maven project. So to know if this bad code is not dead and deprecated, we have a risk metric that looks at commits and map Jira tickets. This component has 28 major tickets and a blocker in it, so this component is rather critical and causes problems that have a high impact on our customers. Let us have a look on the design issues of this component. There's a global butterfly. I love this one. Can really become painful to resolve this. Our dependency plot helps to find all incoming and outgoing dependencies. Why butterfly? Well, if I merge to one picture, it looks like a butterfly. Let us have a look on the metrics of this component. This component has too many lines of code. Its cohesion is not good. Coupling too. This component screams that it has unresolved bugs in it. That just wait to hit production. Okay, you're big, bad, and ugly. Let's give you some surgery to make you beautiful again with our partitioning editor. The lines you see are the interfaces or calls between attributes and functions inside a class or component. Unconnected dots are functions or functional groups that are not called from inside the component. They might be dead code or can be extracted immediately. Circles are functions and rectangles are attributes. When we unfold a functional group, so we can always replace an interface with two APIs that are speaking to each other and extract the functions and attributes into another component. For example, we can go completely crazy and push the granularity slider to 55. This shows me that there are 5 central pieces, where 2 are heavily interconnected, indicated by those thick lines. When we push granularity to 5, we get 3 massive components that could be broken down by creating 14 APIs this would have taken hours and hours of work to find this structure as a possible refactoring breakdown. Are you interested to know more? Connect to me or follow me over LinkedIn, Twitter, or Xing. I'm Sebastian Strebig from Bowl Technologies.